Let's explore regular expressions in C++, focusing on pattern matching using the C++ Regex library. Regular expressions are powerful tools for working with text. They allow you to search, match, validate, and manipulate strings based on defined patterns. Regular expressions are extremely useful in situations where you need to process or validate textual data. To use regular expressions in C++, you will first need to include the Regex library. The C++ Regex library offers several classes for handling regular expressions. Key components include std, regex, which represents a regular expression std, smatch, which contains the results of a string match std, regex_search, which searches for a pattern within a string, and std, regex_match, which checks if an entire string matches a specified pattern. Here's a basic example of how to include the necessary headers and set up a simple regex pattern matching. First, include the iostream, regex, and string headers. Then inside the main function, create a string variable called text and assign it the value hello, C++. Next, create a std, regex object named pattern, initializing it with the regular expression C \+++. Note that the backslashes are used to escape the plus sign since plus has a special meaning in regular expressions. More code will follow in the next examples. Now let's dive into basic pattern matching using the std, regex_search function. This function helps you find a pattern within a string. Here's an example. Include the iostream, regex, and string headers. Then, inside the main function, create a string variable called text and assign it the value contact, john@example.com. Create a std, regex object named pattern, initializing it with the regular expression \w plus at \w plus \w plus. This regex pattern is designed to match email addresses. Declare a std, smatch object named matches, which will store the results of the search. Use std, regex_search to search for the pattern within the text, storing the match results in the matches object. If a match is found, print the matched email address to the console. The output of this program will be found email, john@example.com. It's important to understand the difference between std, regex_match, and std, regex_search. The std, regex_match function checks if the entire string matches the given pattern. For example, if you have the string ABC 123 and the pattern A plus 0 to 9 plus, the regex_match function will return true because the entire string matches the pattern. On the other hand, the std, regex_search function checks if any part of the string matches the pattern. For example, if you have the string hello ABC 123 world and the same pattern th plus 0 to 9 plus, the regex_search function will return true because the substring ABC 123 matches the pattern. Thus, use regex_match when you need to validate the entire string against a pattern, and regex_search when you are looking for a pattern within a larger body of text. Capturing groups allow you to extract specific parts of a matched string. Capturing groups are defined using parentheses in the regular expression pattern. Here's an example that demonstrates extracting matched groups from a date string. Include the iostream, regex, and string headers. Then inside the main function, create a string variable named text and assign it the value date, November 15, 2023. Define a regular expression pattern to capture the year, month, and day date, \d4, \d2, \d left brace 2 right brace right parenthesis single quote. This pattern includes 3 capturing groups, each matching a part of the date. Use std, regex_search to find the pattern in the text and store the results in the matches object. If the pattern is found, extract the year, month, and day from the matches object and print them to the console. The output will be year 2023, month 11, and day 15. The std regex_replace function allows you to replace parts of a string that match a regular expression pattern. Here's an example of a basic replacement. Include the iostream, regex, and string headers. Inside the main function, create a string variable named text with the value hello, world. Define a regular expression pattern to match the word world. Use std regex_replace to replace world with C++ in the text. The result will be hello C++. You can also use back references to rearrange or modify the matched text. Include the iostream, regex, and string headers. Inside the main function, create a string variable named text with the value John Doe. Define a regular expression pattern with capturing groups for the first and last names. \\w plus, \\w plus right parenthesis single quote. Use std regex_replace with back references $2, $1 to rearrange the names. The result will be Doe John. To find multiple matches in a string, you can use a loop with std regex_search. This allows you to iterate through all occurrences of a pattern in the text. Let's look at an example where we find all IP addresses in a string. Include the iostream, regex, and string headers. Then inside the main function, create a string variable named text containing multiple IP addresses. Define a regular expression pattern to match IP addresses. Initialize and smatch object to store the match results. Get iterators to the beginning and end of the text. Use a while loop with std regex_search to find each IP address in the text. Inside the loop, print the matched IP address. Update the position iterator to start searching from the end of the previous match to find the next match. This way you can extract all IP addresses from the text. The C++ regex library provides various flags and options to customize the behavior of regular expression matching. These flags can control the syntax and matching options. Syntax options include std regex, ECMA script, which is the default syntax and is similar to JavaScript regular expressions std regex, basic, which uses POSIX basic regular expressions std regex, extended, which uses POSIX extended regular expressions and std regex, awk, which is specific to the awk language syntax. Matching options include std regex, icase, which performs case-insensitive matching std regex, no-subs, which tells the regex engine not to store sub-expressions, potentially improving performance if you don't need to access captured groups, std regex, optimize, which optimizes for matching speed, and std regex, collate, which uses locale-specific collation for comparing characters. Regular expressions are highly useful for form validation, ensuring that user inputs meet specific criteria. Here are examples for validating email addresses and passwords. First, include the iostream, regex, and string headers. Create a function validate email that takes an email string as input. Inside the function, define a regex pattern for a valid email format. Use std regex_match to check if the email matches the pattern and return true if it does, otherwise return false. Create a function validate password that takes a password string as input. Define a regex pattern that enforces password requirements such as minimum length, and the inclusion of at least one uppercase letter, one lowercase letter, and one digit. Use std regex_match to check if the password meets these criteria, returning true if it does and false otherwise. Here are some best practices to keep in mind when working with regular expressions in C++. Compile regex patterns once and reuse them multiple times to improve performance. Use raw string literals, indicated by R, for complex patterns to avoid excessive escaping. Always handle regex exceptions such as std regex_error to manage potential errors during pattern compilation or matching. Thoroughly test your patterns with various edge cases to ensure they work correctly. Finally, consider performance implications when working with large datasets and optimize your patterns accordingly. In summary, the C++ Regex library offers powerful tools for pattern matching and string manipulation. Use regex_match for validating entire strings, regex_search to find patterns within text, and regex_replace for string transformations. Capturing groups are useful for extracting specific parts of matches, and regex flags can customize matching behavior. With these tools and practices, you can effectively use regular expressions in your C++ projects. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.